Welcome back to Math Enhancement. In this video, we're going to continue how to solve quadratic equations in one unknown, particularly how to solve quadratic equations using completing the square technique. Okay, so we have 3 examples to solve to illustrate and show you how you're going to do completing the square in order to obtain the roots or the solutions of the quadratic equation. So ang first question natin dito is, when do we use completing the square? Okay. Unlike the previous method, the previous method we discussed on solving quadratic equations is by factoring. So number 1, if you're not able to factor, to simply put into factors the trinomial, okay, that means it calls for another method. Okay, number 2, if you're not able to factor it out by the special products that you know, by the factoring methods or techniques that you know, one technique that you can use is completing the square. Okay, kailan ba natin ginagamit si completing the square, or when do we use this completing the square? Of course, you have a complete square, okay, or should we say, completing the square is a process of transforming a trinomial so that it becomes a perfect square trinomial. Okay, halimbawa, saan ba nanggagaling yung perfect square trinomial? For example, you have x minus 2. This is a binomial. Okay? If you square this binomial, it will produce a trinomial. And that trinomial that will be produced from squaring a binomial, you call that a perfect square trinomial. So question is, how do we expand this? Of course, we take the square of the first term, okay, plus the product twice the product of the first term and the second term. So that makes it negative 2 plus the second term squared. Okay, so what we did was square the first term, take twice of the product of the first and the second term, and then add to that the square of the second term. Okay, and then if we expand that, or if we simplify what we have, that would be x squared minus 4x, okay, plus 4. And we already learned techniques or shortcuts on how we're going to do this, okay, but definitely, your x squared minus 4x plus 4, this is an example of a perfect square trinomial. If we check that in reverse, or if you have a perfect square trinomial, how do we factor it? How do we factor this so that it becomes the square of a binomial? Definitely what we do is, we take the square root of the first term, that's x. We copy the sign of the middle term, so that's negative. And then we take the square root of the last term, and that's 2. Okay? Square that, and that will produce this perfect square trinomial. So if we cannot, if the trinomial that you have cannot be, you cannot find out how to factor it, number 2, you know it is not a perfect square trinomial, then what we can do is complete the square so that it becomes a perfect square trinomial. So to do that, let me show you the first examples. Let's say you have letter A, 2x squared plus x minus 3 is equivalent to 0. Okay, definitely this one is not a perfect square trinomial, first and foremost because of the quadratic term. Your quadratic term here has a numerical coefficient. A perfect square trinomial can actually have a quadratic term with a coefficient greater than 1. But if the quadratic term's numerical coefficient is actually not a perfect square, that already gives us an idea that it is not a perfect square trinomial. So, we can make it into a perfect square trinomial, and this is what you're going to do. The easiest way is to make sure that the quadratic term has a numerical coefficient that's equivalent to 1. So if this has a numerical coefficient which is 2, what we can do is divide both sides by 2 so that we'll be able to create a numerical coefficient for the first term, or for the quadratic term, be equivalent to 1. So let me get my pen. I'll divide both sides of this by 2. Okay? And that will create, by separating into smaller fractions, that will create 2x squared all over 2 plus x over 2 minus 3 over 2 equivalent to still 0, because you have 0 divided by 2 still 0. And that makes the first term, or your quadratic term, cancel its coefficient. Thus, you have x squared plus x over 2 minus 3 halves all over equal to 0. Okay? The next thing you're going to do is move the constant term to the right side of the equation. So in that sense, you have to move this, okay, move the constant to the right side of the equation. It will create an equation that looks like this. You will have x squared, okay, plus, let me write this as 1/2 x. That means I separated the numerical coefficient with the literal coefficient. I'll leave a space after that. That would be equivalent to positive 3 halves. Okay, this is where completing the square enters. Okay, you're going to find out what should I add to the left side of the equation to make the left side a perfect square trinomial. Of course, whatever you added on the left side of the equation, you also have to add it, okay? You have to add it as well to the right side of the equation to the right side of the equation to make the equation balanced. Now, in making the left side of the equation a perfect square trinomial, you have to go back to this principle that you have to come up with this constant that will make it a perfect square trinomial. So if you're going to notice, what you have to determine is what is the second term of the binomial. Obviously, the first term would be x because you already have x squared here. So definitely, it came from a first term of x. So parang you already have an idea that one of the terms is x. Definitely, the middle term is multiplied by 2, diba? To be able to produce this, okay, to be able to produce a middle term, which is 1/2 x, that is from twice the product of the first term. We definitely know the first term should be x, because you have x squared. You take square root of that, that gives you, okay, taking the square root of the first term or the quadratic term, that gives you your first term in the binomial. And what should it be multiplied so that it produces 1/2 x? In that case, you have to divide your middle term by 2x, right? Okay. You have to divide your middle term by 2x and it will produce 1/4. That's 1/2 x divided by 2x. That creates 1/4. And that means I have to multiply this by 1/4 to make or to produce 1/2 x as a middle term. Okay. In that sense, 1/4 becomes your second term. Okay, and remember, the second term is squared to become the constant term of the perfect square trinomial. So if I'm going to square 1/4, okay, that means I will have my equation be equivalent to x squared plus 1/2 x, okay, plus that would be my second term, which is 1/4 quantity squared. And whatever you added on the left side, you have to add it on the right side as well. That means I have 3 halves here plus the same term, 1/4 squared. Okay, again, where did I take, or in shortcut, how are we going to produce that 1/4? Take your middle term, that's 1/2 x. Okay, make sure this is x squared. Make sure that the coefficient of the quadratic term is 1. Okay, take your middle term, that's 1/2 x, and divide it by 2. Okay, divide it by 2 and by the square root of the first term, which is x squared. So the square root of that is x. So your middle term will be divided by 2 and x, and that will produce a constant. That constant will serve as your second term in the binomial. Okay, in this binomial. After that, that second term must be squared. Okay, that must be squared. And that is what you're going to add to the left side of the equation and to the right side of the equation. In turn, it will look like this. That's x squared plus 1/2 x plus 1/16 is equivalent to 3 halves plus 1/16. In that sense, this is now a perfect square trinomial. And again, going back to this principle, how do we factor a perfect square trinomial? Take the square root of the first term, copy the sign of the middle term, take the square root of the last term. So, if you have this as a perfect square trinomial, I have to take the square root of the first term, that would be x, copy the sign of my middle term, that would be plus, and take the square root of the last term, and that would be 1/4. Okay? Take the square of this binomial and it will produce this trinomial. On the right side, you just simplify as is. So you have 3 halves plus 1 over 16. That's actually, 3 halves is actually 24 over 16. Diba? If you multiply the numerator and denominator by 8. Okay, so that you get an LCD. So you get 24. This is 24 over 16 plus 1 over 16. So you get 25 over 16 for the right side of your equation. Okay, in that sense, what's the next thing to do? The next thing to do is free the left side of the equation or solve for x. Okay, the next thing to do is solve for x. And we do that by simply taking the square root of both sides. Okay, taking the square root of both sides, that will produce x plus 1/4 is equivalent to, of course, if you take the square root of a constant, that produces a positive and negative answer. So that's positive negative 5 over 4, right? Take the square root of 25 over 16, that's 5 over 4. And then, you transpose 1/4 to the right side, okay? And that will result to x being equivalent to a positive negative 5/4 minus 1/4. Therefore, you produce two roots for x or two answers for x. One is that x is equivalent to the positive of 5/4 minus 1/4, and the other is that you produce a negative of 5/4 minus 1/4. Simplifying that, you get one root be equivalent to 5/4 minus 1/4, that produces 4 over 4, so that's positive 1. Okay, and then you have negative 5/4 minus 1/4, that's actually negative 6 over 4. Okay, negative 6 over 4, if you simplify that, that's negative 3 halves. And these two will represent the roots, okay? These two will be representing the roots of our quadratic equation, okay? Going back to the problem given to us is that you have 2x squared plus x minus 3 equivalent to 0. Actually, if you're already excellent in factoring, this particular question can actually be factored. You just have to think of what binomial should be multiplied so that it creates this trinomial. So first and foremost, of course, you have 2x, right? 2x multiplied by x, that will produce 2x squared. The next thing we have to do is think of factors of negative 3. So that could be positive 3, negative 1, negative 3, positive 1, okay? And then, by trial and error, simply write them in your binomial. So you have, if this is positive 3 and this is negative 1, okay? If I take, diba, first, outer, so that's negative 2x, inner, so that's positive 3x. And if you take that sum, will it produce positive x? And that's correct. So if it does, therefore, this is the factored form of this equation. So you have there 2x plus 3, okay, times x minus 1 equivalent to 0. We were instructed by factoring to get each of the factors, so that's 2x plus 3 and x minus 1, okay, and equate it to the right side of the equation, which is 0. In that case, you will have, on the right side, you have x equivalent to positive 1, okay. On the left side, you will have a 2x equivalent to negative 3. We divide both sides by 2, and you get x equivalent to negative 3 halves, which justifies that x is equivalent to negative 3 halves or positive 1, and which are our answers by completing the square. Okay. Actually, you can still further prove that your roots are correct by simply taking your calculator. If you have your calculator, there's no problem in using that. But of course, we cannot always be dependent on our calculator, so we must gain that skill that we need mathematically, right? So we're going to use polynomial in the second degree and substitute the coefficients of the quadratic equation that we have. So this is the quadratic equation. So you have 2 as coefficient of x squared, and then you have 1 as coefficient of x, and then your constant is negative 3. We simply press equals again, so that will produce negative 3 halves, okay, this one, and positive 1, this one. That way, we're able to check that our answers are correct, okay? Let's move on to the next example. So if I'm going to take letter B, our second example is 6x squared plus 25x equivalent to 14. So, of course, as a rule, your quadratic equation must be equated to 0 before you proceed on solving. So, you have there, Okay, so you have there 6x squared plus 25x minus 14 equivalent to 0. Of course, you have to check if you can factor it first. If not, then proceed to completing the square. Okay, so definitely this one can't be factored, even though we think of factors of 6 and negative 14 that will produce factors. So instead, let's just focus on the solution being discussed on the method or in this video, which is completing the square. So first and foremost, we have to divide both sides by 6. As a rule, that will make the quadratic terms coefficient be equivalent to 1. In that sense, that will be x squared, okay, plus 25 over 6x, okay, minus 14 over 6, and that will create the right side base still be equivalent to 0. Next thing to do is transpose. Okay, transpose your constant to the right. So that will create x squared plus 25 over 6x. Leave a space equal to positive 14 over 6. Okay, and then we have to divide the middle term, right? Divide the middle term by 2x, just like what we did previously. So if I'm going to divide this by 2x, that will create 25 over 6x divided by 2x. That will create 25 over 12. Okay, square this and put it as my third term to make the left side a perfect square trinomial. So that means I have to add here 25 over 12 quantity squared. So add 25 over 12 quantity squared. And that will create, okay, the left side be equivalent to x squared plus 25 over 6x plus, okay, let's take our calculator to assist us on this matter. But definitely that's 25 over 12 squared. So definitely that's 625 over 144 over 144. That's equivalent to 14 over 6. You can simplify that fraction if you want. There's no problem with that. Plus 625 over 144. Okay. Simplifying the left side. So by factoring, that will produce x plus, because we're taking this sign, the square root of this is obviously your 25 over 12. Quantity square that. Okay. So this trinomial is from the square of this binomial, equivalent to, so that's 625 over 144. We have to add 14 over 6 to that. And it will produce 961 over 144. The next step to do is take the square root of both sides of the equation. Okay. And that will produce the left side as x plus 25 over 12. And the right side be equivalent to a positive, negative. Let's take the square root of this. 31 over 12. Okay, positive, negative, 31 over 12. The next thing to do is again, transpose this constant so that we'll be able to solve for x on the left side of the equation. So that will produce x equivalent to a positive, negative, 31 over 12 minus 25 over 12. Okay, in that sense, you will have two answers for x. So you will get x be equivalent to the positive 31 over 12, okay, minus 25 over 12. And on the other side, you will get x equivalent to the negative of 31 over 12, still minus 25 over 12. On the left side, you will get this as 31 minus 25, that's 6 over 12, or simply 1 half. On the right side, you will get x be equivalent to, that's negative 31 minus 25. So you will get that as negative 56 over 12. Or simplifying that, you get negative 56 over 12. You produce negative 14 over 3. And there you have the roots of the given quadratic equation. Okay, let's check that again using our calculator. So let's get polynomial degree, second degree. Okay, and let's substitute the coefficient of the equation given. So you have 6 for the x squared term, 25 for the linear term, and then you have negative 14 for the constant. We press equals again, and that produces negative 14 over 3 and positive 1 half. And that proves that our answer is correct. Okay. Next, let's proceed to the third example. under completing the square. So your third example is a fraction. You have there 1 all over x minus 2 plus 1 all over x plus 2 equivalent to 1. So as instructed, we have to remove the fraction. So you have to multiply this equation by its LCD, both sides of the equation. So I have to multiply both sides of the equation by x minus 2 and x plus 2. Okay, I'll do that on the left side of the equation as well. So let me move this. So I will have to multiply this. Okay, I have to multiply this with x minus 2 and x plus 2 as well. Okay, in that case, distributing this to the first term, that will cancel x minus 2. I'll have x plus 2 in the numerator plus, okay, multiplying this to the second term, that will cancel x plus 2. I'll have x minus 2 equivalent to, on the right side, I will have this, x minus 2 times x plus 2. Okay, the next thing to that is simplify. Of course, the left side of the equation gives me 2x. Positive to negative 2 gets cancelled. The right side of the equation needs to be expanded. So this is the product of the sum and difference of the same two terms. So that creates difference of square. So you get there x squared, okay, minus 4. The next thing we do is transpose, of course, making sure that the equation is equated to 0. So you have there x squared minus 2x minus 4 equal to 0. Okay, what I did was I transposed this to the right side. So that creates 0 equal to x squared minus 2x minus 4. And then I just switched the sides of the equation, or the members of the equation. So you get x squared minus 2x minus 4 in the left side, equivalent to 0. The next thing to do is, of course, complete our square. So in completing this square, you have to transpose the constant to the right side. That would give us x squared minus 2x equivalent to positive 4. So we have to divide the middle term. That's 2x, okay? We have to divide 2x by 2x, so that produces positive 1. And then we square that, so that would be the term we have to add on both sides of the equation. Okay? Next thing to that is factor the left side of the equation. This is already a perfect square trinomial. So we get the square root of the first term, that's x. Copy the middle term, that's minus. And then take the square root of the third term, or the constant, that's positive 1, and square that. Okay? Of course, there will be times that you can you can check along your solution, so that maaga pa lang, or as early as possible, you can identify if there's something wrong in your solution. So if you try to expand this, it should produce this trinomial. So you have x squared minus 2x plus 1. So that's correct. That's equivalent to 5. The next thing we do is, we take the square root of both sides, okay, and we get there x minus 1 be equivalent to the positive and negative 5. And then transpose, solving for x, that will produce positive negative 5 plus 1. Thus, you get the roots x equal to positive 5 plus 1. Sorry. That's supposed to be positive negative square root of 5. Okay, positive negative square root of 5 plus 1. Okay, so that will result to one root that is equivalent to positive square root of 5 plus 1. And the other root be equivalent to the negative square root of 5 plus 1. Okay, so since this is a decimal, it will create a decimal. You can have a radical expression as an answer. So we'll leave this as square root of 5 plus 1 and negative square root of 5 plus 1. Again, we can check that with our calculator. So let's get our calculator and use polynomial in the second degree. So let's get the transformed quadratic equation that you have. So this one, and use its coefficients as 1, negative 2, and negative 4. Okay, pressing equals, that will create your first root, it's negative square root of 5 plus 1, and your second root is square root of 5 plus 1. And that concludes how we do completing the square in solving for the roots or the solutions of your quadratic equations in one unknown.